Okay, so here's another our topic: electric current, resistance, and Ohm's law. What do you think is the connection between electricity and electric current? Actually, electricity has two types. The static electricity, in which we have already discussed in our previous topics, which is which means or the we already knew that it is produced by rubbing two objects, and the other one is electric current. There's no much difference between electric current and electricity because both do carry electric charge. Electric current is defined to be the rate at which charge flows, or simply the movement of charge. It is the flow of electrons or the negatively charged particles. When there is flow of electrons or the flow of electrons in electric field, that causes to have electric current. Now, the term current here is analogous to the term we usually hear or use in a river. So, this is analogous to a river current. When we say current, that's the flow of water in river. So, the same with electric current, the flow of electric charge, not the flow of electricity. Do not use the flow of electricity. It is the flow of charge or the electrons. What flows on electric current is the negatively charged particles or the electrons, not the electricity. What flows on a river current is the flow of water. So just like that. In equation form, we have this relationship between the current I and charge and of course time. So where I here is the variable used for electric current, of course its unit is in ampere, which was named after Andre Marie Ampere. And Q here is the charge or in coulombs, and time, of course, its base unit is in seconds. Examples in utilizing the relationship between current, charge, and time. A. What is the current involved when a truck battery sets in motion to 720 charge of columns of charge in 4 seconds while starting an engine? So, solution for this problem, let's use the formula I is equal to Q over T, which is equal to, where Q is given to be 720 columns and time is 4 seconds. So the electric current here is 180 ampere. And for letter B, how long does it take? How long means you are to solve for the time. How long does it take one coulomb of charge to flow through a handheld calculator if a 0.300 milliampere current is flowing? So we have here the charge is 1 coulomb and the current is 0.3 milliampere. So times 10 to the negative 3. And that is equal to 3.33 times 10 to the power of 3, positive 3 seconds. Okay. Next example, a steady current of 2.5 ampere flows in a wire for 4 minutes. Given are the electric current, which is 2.5 ampere, and the time, which is 4 minutes. How much charge passed through any point in the circuit? So using the same formula, you just have to um, tawag niyan, transpose and uh, we just have to derive the formula. So where Q is equal to current times the time. So 2.5 ampere times the time, which is 4 minutes. We just directly convert that one into seconds back to its base unit so that the the remaining unit for the charge is also is back into columns. So 600 columns. The answer is 600 columns. Ohm's law was first demonstrated experimentally by George Simon Ohm. It states that current in a metal wire is directly proportional to the voltage applied, where this relationship between current and voltage is known as Ohm's law. And this relationship also can be viewed as a cause and effect relationship, where the cause is the voltage and the effect is the I, or the current. Because without voltage supply, though nandiyan na yung resistor, without the voltage supply, there will be no electricity, or there will be no electric current produced in a circuit. Resistance, by the way, here is the electric property that impedes current. What do we mean by impede? The word impede means resist. So from the word resist, I have mentioned a while ago the analogy between electric current and river current, right? Now, how much current flows in a wire depends not only on the voltage but also on the resistance of the wire. And it is not just resistors or electric properties like resistors that is capable of impeding or resist the flow of current. Also, the wire itself is an example of a property of electric property that can resist the flow of electric current. But that would depend on the length of the wire, or the length of the wire, and the how far will that wire go. For example, you have tawag niyan, yung for example, meron kayong saksakan dito sa JBB building, and then dun nyo ilalagay yung extension wire dun sa facade. O, di ba masyadong malayo? The length, consider mo yan, and kung gaano siya kalayo napunta. So that somehow, konti lang, pero makaresist yung wire sa electric current. Okay? And this also, where V in this relationship, Ohm's law, this is called Ohm's law, where electric current is proportional to the voltage applied, where V here is the voltage in volts, R is resistance in ohms. This is ohms, and its symbol for the unit is omega, and this one is the symbol of resistance in a circuit. For example, what is the resistance of an automobile through which 2.5 ampere flows when 12 volts is applied to it? So as you can see, here's an example of an electric circuit. We have here the source of 12 volts, the voltage source. This arrow here, the direction is towards right, or the direction of the electric current is clockwise or counterclockwise. Okay, so yan yung direction. This arrow here implies the direction of the electric current, and this one is the resistance. This is the symbol of resistance in a circuit. Okay, so let's use the formula of Ohm's law. I is equal to V over R. Since we are to solve for the resistance, we have to derive this formula. So R is equal to voltage divided by I. So R is equal to 12, given voltage is 12 volts, divided by the I, or the electric current, 2.5 ampere. So the answer here is 4.80 ohms. In its units, instead of using the word ohms, you can just write the symbol or draw the symbol of omega. So that's ohms. Okay? Next example, in the circuit below, if you're given a circuit like this, determine the current I. So we have no idea kung saan yung flow ng I. Of course, papunta yun dyan. We have here the voltage source of 5 volts and a 10 kilo ohm resistor. We are to solve for I. Using the Ohm's law, I is equal to 5 volts divided by 10 kilo ohms. So I is equal to, or the electric current in this circuit is 0.5 milliampere. Ohmic materials. Ohm is the unit of resistance. Therefore, ohmic materials refers to materials that can resist. Here's some of the examples. We have electrical wires, LEDs. LED means light emitting diode. Light emitting diodes, yan siya. So, ito madalas nyo ito nakikita sa mga Christmas lights, yung sa mga light indicators, or sa mga tawag yan, electronic devices, yan. Resistors, here, we have here resistors. You're familiar with this since I know you have seen all these things. Especially resistors, saan yan madalas nakikita? Sa mga motherboards, sa mga circuit boards ng radios, TVs, and any electronic devices. Okay? And meron yan silang mga colors. Why? These colors of the resistors indicates the resistivity of the material. Let's proceed. Superconductors. Superconductors are non-ohmic materials because they have no resistance at all. Prominent examples of superconductors include aluminum, niobium, magnesium diboride, cuprates such as yttrium, barium, copper oxide, and iron pnictides. These materials only become superconducting at temperatures below a certain value known as the critical temperature. The superconductor with the highest transition temperature at ambient pressure is the mercury, barium, and the cuprates yan siya. The cuprates of mercury, barium, and calcium at around 133 Kelvin. There are other superconductors with high recorded transition temperatures, for example, lanthanum superhydride at 250 Kelvin, but these only occur at very high pressures. But the well-known example of a superconductor is actually a salty water. Sa dagat, yan. That is an example of superconductor. That's why yung mga umiihi, we know that our urine is salty, right? Pag, hindi naman dahil natikman ko na siya. Hindi we just know that it's salty. Salty siya kasi nga urine yun eh. Yun yung dun lumalabas yung mga ano natin, di ba? Kapag nga may sakit tayo sa bato, kasi because of too much intake of salt, masyadong intense din yung color ng ating urine. And kapag yung mga tulad ng mga nababalitaan natin na umiihi sa mga lasing na tao, umiihi dun sa mga poste ng tawag niyan, electrical post, 'di ba? Nakukuryentehan. That is because our urine is an example of salty liquid in which it is considered as superconductor. Okay, now let's proceed. V is equal to IR. This expression for V can be interpreted as the voltage drop across a resistor produced by the flow of current I. If for just like this one in this illustration, we have here the voltage, the source, and we have here the resistance R. If we're going to tap a wire here on both sides of the resistor and using a voltmeter, you can see that in these points of a circuit, it will be seen to be the voltage across here, the voltage source, it will be seen to be at its maximum voltage source. But if ilipat mo yan dito, yung wire na yan ng voltmeter sa resistance or resistor sa circuit, it will be seen as decreased yung source niya, yung voltage source. mag-decrease siya pagdating dito sa resistor. And that is what we call voltage drop. The voltage drop. Because niresist ng resistor yung source. Okay? That's all. I think that's all. In our next topic, we're going to discuss about the devices measuring currents and voltages and current sensitivity, and of course, the parallel and series circuits for resistors. Thank you for listening. Bye-bye.
I never made it, but I know